Welcome. Now it's time for us to test our last method of the class because this is the piece which is red is not unit tested, which means our code that we see for the class, the coverage is not 100%. The code coverage of the class should be always 100%, which means every line in your class should be already unit tested. So let's go ahead and see how can we test this method for unit test. So back to our controller test class and create a method here void test multiply. Remember this what we are testing can be applied for any class that you want to test for any use case. Right now we are just doing a test of a dummy controller class with which has method and takes some parameter. So now what we want to do is we want to test this piece of code. What we are saying here, let's try to understand. So if as a human, what would I do is for testing, I would make sure I will call this method from my controller class or test class, and then I should pass the values. So what should be the value? Especially the value with the three fields. Get name1, get name2, num2, get num3, and 4. I should pass all these values. So let's do this much first. So first we will annotate this method at the rate test and at the rate display this. So let me give some description. Test multiplication. All right. And now when calling the calculator function, let's see what happens. So calculator dot multiply. So it expects to pass this. So let's go ahead and create that. So what we will do is we will say calculator DTO equal to new calculator DTO. All right, and now we have to set the value here. So I'll say calculator DTO dot set num1, and I can pass the same value which we have initialized at the top. Similarly, calculator DTO dot num2 set num2 is num2, and calculator DTO dot set num3 num3. We also have a calculator DTO dot num4. So for that, I'm going to just say 2.0. Now I have to pass this. That's also good. Perfect. We did this. And now it's going to return me a result. So let's check. Yes, it's going to return us a result, but not directly, but inside, wrapped inside response entity. So let's grab that. So here I'm going to say response entity of double. This is response entity equal to okay. And now what I have to do is assert equals, and I have to pass the actual and the real value. And from where are we going to get the real value? Response entity dot get. Here is the body. If we pass this, then it's going to give us the double value. All right, but what will be the expected now? So let's calculate this. So we'll go with calculator and we'll say 3.5 into 3.5 into 3.5 into 2.0. Let's see. So it says 85.75. So that should be our expected value. 85.75. Perfect. Now let's go ahead and run this test. So and see if it is passing. The test passed, that's great. But we could have also done another assertion here. Here we are also saying HTTP status code will be 201 created. So we could also do another assertion. The more assertions we do, the better is the quality of our code. So I will say HTTP expected is HTTP status dot created dot value, which will give me int. And then what we are getting here is we will say response entity dot get status code value, this one. So this gives us an int. If I now run the test, this both should assertion should pass, only then our test will pass. So let's run it. The test pass. But now let's say a developer by mistakenly he goes and changes this to OK, and now he doesn't updates the test. So now our test, when it will run next time, it's going to fail. And that's where we will come to know that there was something changed in the code which hasn't been tested. So now our test failed and it says expected value was 201 and actual was 200. We could give it a more user-friendly message here by passing the third parameter. Here we say expecting the status as created. So if I run the test now, instead of giving this default, we will get a much more user-friendly message. So the last parameter in assert equals is, so you see it says expecting the status as created. So the last parameter here in any assert is the message parameter. It's an optional one, and but this message will only be printed if your test fails. If your test passes, it doesn't print. So now as a developer, you will be asked, all right, you modified the code. What's the reason you modified the code? Then you are going to say, okay, because of the new business use case, I had to modify the code. That's fine. Then now you will be asked to also modify the unit test. And then you will come here and then as a developer, you are going to modify the value of this as okay. And now you will also say expecting the status as okay. So now if you run, the test will pass. So this is how it works, and you will be your test will pass and you will be allowed to bring these changes to production or to the higher environment. But now this unit test coverage is still not 100%. So let's run our test in a coverage mode. So click here and click run coverage, run with coverage. And you will see this pop-up will appear here, and now as soon as we go add to suite, and if we go to our class now, it is green. Every line of code which is executable is covered. See, nothing is red, everything at the corner is green. Don't go by this line coverage, go with the executable code. So this is covered, this is covered. Whatever is inside the function which is getting executed, that should be covered as or unit tested. So we have now achieved 100% test coverage. So you can click here in this corner and this will disappear flap. Perfect. So now we know how to write unit test for a complete class of logic from a test file and then also run the coverage. And we also saw the importance of unit test, because if a developer modified the code without modifying the test, then he will be caught because the test will fail. So that's the power of unit testing. Thank you for watching this video. Bye bye.